Welcome to the fourth part of VCAA Specialist Maths 2021 exam papers. In this video, we will solve exam paper 2, section A, questions 1 to 5. Statistically, most students did well in questions 1, 2, 3, and 5. However, more than half of the students had problems with question 4.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA Specialist Maths exam paper series. This is section A of 2021 exam 2 paper. There are total 20 multiple choice questions in section A and 6 extended response questions in section B. In this video, we will present you question 1 to 4 in section A. Let's start with question 1. As you can see, the question is to find the number of asymptotes of the graph of the function f of x, which equals the reciprocal of the sum of sec of 3x plus 3 over 2 over the closed interval from negative pi over 6 to pi. As we know, the period of sec of 3x is 2 pi over 3, and the length of the interval is 7 pi over 6. Since there are 2 asymptotes in one period, the number of asymptotes can be calculated, which equals 2 multiplied 7 pi over 6, or divided by 2 pi over 3, which equals 3.5. Hence, there are 3 asymptotes in the closed interval. Alternatively, we may plot the graph of the function in your CAS calculator and find out the number of asymptotes there. So, the answer for question 1 is B. Question 2 is to find the implied domain of the function f of x, which equals arc cosine of logarithm base e of bx, where b is greater than 0. According to the rule of the function, as well as the properties of arc cosine function, logarithm base e of bx is greater than or equal to negative 1, but less than or equal to 1. Since logarithm base e of 1 over e equals 1 and logarithm base e of e equals 1, logarithm base e of bx is greater than or equal to logarithm base e of 1 over e, but less than or equal to logarithm base e of e. Hence, we have bx is greater than or equal to 1 over e, but less than or equal to e. Because b is a positive number, it follows that x is greater than or equal to 1 over be, but less than or equal to e over b. So, the answer for question 2 is E. Question 3 is to find the coordinates of the local maxima of the function y equals the reciprocal of the total of cosine of ax plus 1, or in parentheses squared, plus 3, where a is a non-zero real number. According to the rule of the function, it can be observed that y reaches its local maximum when the denominator reaches its minimum, which implies that cosine of ax plus 1 equals 0. Because cosine of ax equals negative 1, it follows that ax equals 2k plus 1, or in parentheses times pi, where k is an integer. Hence, when x equals 2k plus 1, or in parentheses multiplies pi over a, the local maximum y equals 1/3. Therefore, the answer for question 3 is E. In question 4, it is given that z is a complex number and its imaginary component is greater than 0. The question here is to find the argument of z multiplies its conjugate over the result of z minus its conjugate, or in parentheses. Here we let z equals x plus yi, which gives the conjugate of z equals x minus yi. Hence, z multiplies its conjugate over the result of z minus its conjugate can be written to the product of x plus yi, or in parentheses, and x minus yi, or in parentheses, over the result of x plus yi minus open bracket x minus yi, close bracket, which can be simplified to negative of x squared plus y squared, or over 2y, then times I. Since the imaginary component y is greater than 0, negative of x squared plus y squared, or over 2y is less than 0. Hence, the argument of z multiplies its conjugate over the result of z minus its conjugate, or in parentheses, equals negative pi over 2. So, the answer for question 4 is A. Question 5 provides a circle function, modulus of z minus 2 minus square root of 3i equals 1, where z is a complex number and its diagram is shown on the screen. The question here is to find the maximum modulus value of z from 5 given choices. Since modulus of z minus 2 minus square root 3i equals 1, the center of the circle is at z0, which equals 2 plus square root 3i. The diagram shows a line drawing from O to z0, and its extension intersects the circle at the point z, where it has the maximum modulus value. Here we continue to work on question 5. Based on the diagram, we notice that the circle is a unicircle. The real component of complex number z can be written to z0 plus cosine theta, while the imaginary component of z is expressed to z0 plus sine theta. Since the argument of z0, which is theta in this case, equals arctangent square root 3 over 2. Accordingly, tangent theta equals square root 3 over 2, and based on the trigonometry identity relations, the values of cosine theta and sine theta can also be calculated. They are 2 over square root 7 and square root 3 over square root 7, respectively. Hence, the complex number z equals 2 plus 2 over square root 7 plus open brackets square root 3 plus square root 3 over square root 7 close brackets I. Hence, its maximum modulus value equals the square root of the sum of the square of its real component plus the square of its imaginary component, which is finally simplified to square root 7 plus 1. So, the answer for question 5 is D.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.